Electron configuration. A quick reminder of some previous concepts. The atom has main energy levels. And each main level consists of sub-levels. While the sub-level consists of orbitals, and each orbital accommodates a maximum of 2 electrons. This means that the electrons in the atom are distributed in the orbitals according to the difference in the energy of the levels, which is known as electron configuration. As we have already known, the sublevel S consists of 1 orbital, so the maximum capacity of it is 2 electrons. While the sublevel P consists of 3 orbitals, that is, their maximum capacity is 6 electrons. Sublevel D consists of 5 orbitals, so their maximum capacity is 10 electrons. While the sublevel F consists of 7 orbitals, then their maximum capacity is 14 electrons. To memorize that easily, we observe that the number of electrons take odd numbers, and we can multiply them by 2 to determine the maximum capacity of electrons. Or, as we can see, the number of electrons increases by 4 each time. So today we will learn the process of distributing electrons at energy level, which is called electron configuration, according to the following principles. Aufbau principle and Hund's rule. So let's get started. Aufbau's principle, which is also known as the building up principle or construction of an atom. It states that the orbitals are filled with electrons according to the increase in their energy. So the electrons are filled starting from the available lower energy orbitals, then the higher energy orbitals are filled. How's that? Let's see. As we have already known, the first energy level consists of 1 sublevel, while the second energy level consists of 2 sublevels. The third energy level consists of 3 sublevels. The fourth and the fifth energy levels consist of 4 sublevels, as we see. Notice that the number of the main level is written beside it. According to Aufbau's principle, the electrons are filled starting from the orbitals of the first energy level, then the higher energy orbitals are filled. But the energy of the orbitals begins to overlap after the 3p sublevel because it was noticed that the energy of the 4s sublevel is less than 3d sublevel. Therefore, the lines are placed obliquely, as we see, to track them during the electron configuration process. Let's learn how together. We start from 1s, then we move from the beginning of the next arrow, then we fill the orbitals of the 2s sublevel, then we move to the beginning of the next arrow to fill the orbitals of 2p and 3s. Then we move to the beginning of the next arrow to fill the orbitals of 3p and 4s sublevels. Then the orbitals of 3d, 4p, and 5s. And so on. To simplify the work, you can put a sheet of paper obliquely and parallel to the lines to make it easier to follow the levels in order. And through the relation of N plus L, we can compare the energy of the level. How's that? Let's apply it in the following exercises together. Which of the following sublevels will be filled first with electrons? 4f or 5s? The solution of this question is to determine which of these two sublevels has the lower energy in order to be filled with electrons first. The energy of the 4f sublevel according to the N plus L rule, where N equals 4 while L equals 3 because the value of the sublevel F equals 3. The result equals 7. While the energy of the 5s sublevel is equal to 5 plus 0 and it equals 5. So as we can see, the energy of the 4f sublevel is higher than the 5s. This means that we will fill the electrons first in the orbitals of the 5s sublevel, then 4f, which means from the lowest energy to the highest. Another example, which of the following sublevels will be filled first with electrons, 5p or 6s? The energy of the 5p level according to the N plus L rule is 5 plus 1 and equals 6. While the energy of the 6s level according to the N plus L rule is equal to 6 plus 0, which is also equal to 6. As we can see, the energy of the two sublevels is equal. So the lowest energy sublevel will be the one with the lowest value of M. That is, we will fill 5p first, then 6s. The second rule of electron configuration is Hund's rule. In this way, the electron configuration is written, where the number of the main energy level is written, and next to it is the sublevel symbol, and above it is the number of electrons in the 2p orbitals, which are distributed according to Hund's rule, which states that the degenerate orbitals will be filled with electrons individually and in the same spin direction. Then the remaining electrons will be added to the orbitals in the opposite spin direction. So let's distribute the 4 electrons to the 2p orbitals, which are 3 orbitals. According to Hund's rule, we will distribute the first 3 electrons individually and in the same direction. 1 electron is left, so we will add it to the first orbital, but in the opposite spin direction. After we get acquainted with the rules of electron configuration, let's now apply that to a set of examples. Our first example is the fluorine, which has an atomic number of 9. So first, we're going to use the energy level chart, and we will add the maximum capacity of electrons as a reminder below the sublevels. So we will start with 1s2, 2s2. As we can see, we distribute 4 electrons and 5 electrons are left of the 9. So we will add them all to the 2p sublevel because the maximum capacity of the p orbitals is 6 electrons. This is the orbital of the 1s sublevel. This is the orbital of the 2s sublevel. And these are 3 orbitals for 2p sublevel. Referring to Hund's rule, we will distribute electrons to orbitals from the lowest energy level to the highest energy level. So we will fill the orbitals of 1s, then 2s, then 2p as we see. Another example is magnesium. Its atomic number is 12. We will start with the 1s2, 2s2, then 2p6. As we see, we distribute 10 electrons and 2 electrons are left of the 12. So we will add them all to the 3s sublevel. Manganese has an atomic number of 25, so its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. As we see, we distribute 20 electrons and we have 5 electrons left. So we will add them all to the 3d level because the maximum capacity of the d orbitals is 10 electrons. Another example is nickel. Its atomic number is 28. So its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. As we see, we have distributed 20 electrons and 8 electrons left. So we'll add them to the next level, which is 3d sublevel. Big thanks for watching. At the end, don't forget to like, share, and subscribe to receive my new videos.